Hello, my beautiful AP CSA students. Welcome to another computer science lesson where I, Goldie, take you through Unit 3, Boolean expressions and if statements. Today's lesson is going over comparing objects, and this is actually our last lesson in this unit. So we're going to talk about those Boolean expressions and how we compare primitive types versus reference data types. So let's start off with the equals to, because that's how so far we've been able to compare two expressions, right? That comparison operator. Now, the equal to compares contents of memory boxes, okay? Which is why for primitives whose data is stored in a memory box, it's the perfect operator to use. So if I have int a is 20, remember what happens is A is my reference, or excuse me, A is my identifier, and 20 is stored in that box. And then same thing with B, 20 is stored in that box. So if I use a comparison operator, the equal to says, okay, look in both of those boxes, A box and B box, and see if what's contained in those boxes is the same. And for primitives, it is. Okay. So what gets printed to the screen? The word same gets printed to the screen because the boxes of both A and B hold the value of 20. Okay. So that equal to does exactly what you would expect it to do when comparing two primitive values. Okay. It does not do what you want it to do when you are dealing with class data types. Okay. So class data types which do include strings, we have to be careful because what we store in that memory box is actually a memory location pointing to a different address. Okay. Now strings are a little tricky because we treat strings a lot of the times like they are primitives, but they are in fact class data types. Okay. So here I have the two examples of how we create strings. String A and string B are created with what we call a string literal. Okay, and string C and string D are created with the actual string constructor. Okay, both are accepted ways of creating a string in Java. Okay, now the thing you have to remember with the way they are declared. Okay, so A is our reference, and A actually doesn't hold the string AP CSA. It holds the memory location of AP CSA. Okay. Holds the memory location. Same thing with B. Now the thing with B, whenever a string literal is created in Java, Java has this efficient way of dealing with strings called a string pool. This is going a little bit beyond the course, by the way, but I just want to explain it fully. Java has what's called a string pool. And what that means is if you created a string literal, like you did in the first line of code there, it's going to create that literal in a string pool. It's exactly what, just picture a big pool, right? If you go to create another string literal and it ends up being the same as something in that pool already, it's going to say, hey, let's save some memory space and have it point to the same string literal. Okay? And that's what's going to happen. They actually end up pointing to the same place in memory. So A and B in this code actually end up getting the same memory address, the exact same contents in their boxes. Crazy, right? And that's just the way Java handles strings. Okay? It doesn't handle objects, other objects like that. It's just a funky way that it handles strings. It's going to make a difference here in a moment. Now with string C and string D, okay, when those are created, actually using the explicit constructor, those create a new object in memory. So it doesn't matter that AP CSA was already in the string pool, you are creating a new object. Okay. Same thing with D. It doesn't matter that another object has already been created the exact same way. When you explicitly create a object with that new constructor, you are constructing new space in memory. Okay? So in memory, this is kind of what it looks like. A and B have the same address because they both point to the string literal. C and D have different addresses altogether because we constructed a new string. Okay. So now when I go down here and I do my comparison, okay, what happens? Well, again, that equal to compares memory location, like what's stored in your memory boxes, Well, A and B have the same memory location. So this is actually going to print off true, okay, because they hold the same memory location. And you can be like, well, duh, Goldie, I wanted to see if A and B both said AP CSA, and it returns true. Okay, I know. It's not the greatest, but it does return true. Okay, now the reason it returns true is not because, well, kind of because they both have AP CSA, but really it's because it's comparing the contents of the box, which they have the same address. Okay, they have the same address, and that's why it's true, because they have the same address. Which makes sense when you come down here to A and C. A and C have different memory locations. Okay, even though they both say AP CSA, they have different memory locations, so this actually returns false. Okay, so that's when it doesn't work like you want it to. Okay, because usually when you're comparing strings, you want to see if it's the same word or the same sentence or the same character. You don't actually want to compare memory boxes, but that's what the equal to is going to do. If you compare B equal to C, that is also going to be false. Again, B and C have different memory locations. And same thing with C and D. Okay, because the equal to compares boxes. Okay. Now, we want a way to be able to compare strings and really compare objects so that we're actually comparing what the contents are and not comparing memory locations. Because truth be told, you're not going to really be thinking of memory locations when you're writing your program. So how can I actually have a for sure way that compares the content? We have a method. Okay? We have a method for it, right? Easiest way to say it. We have a method. It's a built-in method, meaning you don't have to import it, that we compare. Okay? So we compare using the built-in method .equals. Okay? And we are able to compare two strings with the .equals method that actually returns true if the exact same thing is held in both strings. So it actually compares the contents of the string. So if I say A .equals B, that's going to return true, or it's going to return true and then print it off true, okay, because they have the same contents. It's actually going to print true for all of these situations, whereas the equal to did not, because it was comparing what was stored in that memory box. Okay? But all of these are going to print true because it's actually looking at the contents of that string. So it's actually looking at, okay, does AP CSA, does that match this AP CSA? The actual contents itself. Now the .equal to method has already been written for strings, so we don't see that method, we're just able to use it. Okay. And again, technically, because we were able to do A equal B, and it printed true, we still want to use the .equals to compare any type of strings, whether it's a string literal or if it's a string object explicitly being created. It's good coding practice to always use the .equals to with strings. Okay. So even though the equal to worked like you kind of wanted it to work, don't use it in your code. Use the .equals, or I'll come after you. Okay. The last little bit I want to talk about is comparing objects. Okay, so that's comparing strings. We use the .equals to. We can also make a .equals to method to compare two objects' instance variables. Okay. So we've created objects before, we haven't really compared them yet. We are going to learn how to write the .equals method in Unit 5. Okay? So Unit 5, we're going to talk about writing it specifically for our objects. But here's an example of what it might look like. Okay? I have a costume class with a single instance variable, just a string that says what the costume is. You assume costume has a .equals method that works as intended, right? And this is kind of the language used on the computer science exam, meaning that it compares the instance variable contents to see if they are equal, okay? So whenever it says assume the method works as intended, it just means you can use it freely in your program and assume it's going to do what you want it to do. The dot equals method compares contents. It does not compare boxes like the equal to does. So here's an example. I have a costume class. I'm going to create a costume for myself. It's going to be a fairy princess. And I'm going to create a costume for my friend, who's also a fairy princess. Okay. Now, these two objects were created, constructed in memory. And if I use the equal to, it's going to print false. Okay. Because I have two different locations in memory in that box. But if I have a dot equals to in my costume class, a dot equals will compare the actual contents and say, is this instance variable equal to this instance variable? And you want it to return true or false based on if it's true or false. Here it'll print true because myself and my friend are both going to be fairy princesses. Okay. So that's an example of how we use the dot equals with strings, and then also how we're going to use it with objects once we write those methods in Unit 5. Okay, so Unit 5, it's coming up. Okay, and that brings us to the end of our lesson today. So hopefully you guys learned a lot. Thank you so much for following along, and I will see you next time.